All right, so I'm just going to redo this lesson in video form in case from Friday you need to see it again. This is usually a topic that sometimes you need explained more than one time, or if you were absent Friday or whatever the case may be. I'm going to go through these two examples again, and then the third example I'm not going to go over because I'm going to hold off on it and do it in class on Monday. So if you look, number one says, Tom and Jerry are at their local swimming pool. They want to jump off the 12-foot diving board and reach a distance of at least 20 feet. Tom's jump can be represented by one function, which is in standard form. You should be recognizing that at this point. And then Jerry's jump can be represented with a function also in standard form. Okay. And it tells us, so a couple things I'm going to bring my own attention to help me. I have a function here, and I have a function here. And then it also tells me, remember we talked about you always want to be able to make sense of what is x and what is y. It's just going to help you contextually understand the problem. So x is the distance in feet from the diving board. Okay, now if you notice, they don't give you a y. So you need to go back and kind of think about, okay, what could y be? So they're at their local swimming pool. They want to jump off the 12-foot diving board. So there's one context clue. And they want to reach a distance of at least 20 feet. Well, it says x is a distance in feet from the diving board. So that 20 feet is an x value. This 12 feet, think logically about this. When you're on a diving board, you're up in the air, okay? So this 12 feet has to be a height. So that's going to be, you can kind of make a note that y is going to be your height in feet, okay? It's usually a lot of times it's told to you. But sometimes we don't explicitly say it because you can infer from the problem what your y is representing, okay? And then if you look down at the bottom, before I start anything, it says graph each function with y-intercepts, vertex, x-intercepts, and symmetric points. So let's do these separately. I'll do Tom first just because he comes first in the problem, okay? So first thing, it's in standard form, so x equals the opposite of b, which is -2. All over 2 times a, so 2 times -1/3. Okay, now you guys, these are fractions, but notice I'm not picking up my calculator, okay? So -2 all over -2/3 when you multiply those together. You guys remember from 7th grade, when you have a fraction in the denominator, you're essentially having a fraction divided by a fraction, so you multiply by the reciprocal of the denominator, or you flip and multiply. Okay, so you have -2, the top stays the same, times -3/2. So you multiply by the reciprocal of the denominator. Remember, that's really -2/1. Okay, so a couple things are happening here. My 2's are going to cancel, if you want to look at it that way. And your negatives are going to cancel. You're left with 3/1, which is 3. You could also look at it as -2 times -3 is 6, and 1 times 2 is 2, and 6/2 is still 3. Okay. Now, you got a positive x value, which is good because x is distance. Okay, we don't want to have negative distances. And then y, we're going to substitute back in, so we have -1/3 times 3 squared plus 2 times 3 plus 12. So really pay attention to your order of operations here. We have -1/3 times 9 plus 6 plus 12. -1/3 times 9 is -3 plus 6 plus 12. Well, -3 plus 6 is 3 plus 12. We get 15. So our vertex here is 315. Okay. And then you have the y-intercept, okay? Well, with the y-intercept, we know that no matter what, your x is 0. Well, if you go back to Tom's equation, if x is 0 here, the whole x squared is going to cancel out. If x is 0, it's all going to cancel out, so you're just left with 12. Okay? Now, typically the other thing we need is x-intercepts and symmetric points, so we get those from the graph. I'm going to hold off. I'm going to do Jerry, and then I'm going to graph it all at once. Okay? So, let's see. We have Jerry. Sorry, guys. Let's see. All right, so for Jerry, let's see. His function's -1/16. Okay, so x equals the opposite of b, which is -1, all over 2 times -1 over 16. Okay, sorry, that's a 16, not a 10. You have -1 all over 2 times -1 over 16 is -2 over 16. So -1 over -1 over 8. You don't need to show me all these steps. You flip and multiply, you get -1 times -8 over 1. So you end up with a positive 8. So then you take that, substitute it in for y. You have -1 over 16 times 8 squared plus 8 plus 12. Let me just scroll up and double check I got that right. Okay. Let's see. So -1 over 16 times 64 plus 8 and 12 is 20. So -1 over 16 times 64 is -4. -4 plus 20 is a positive 16. Sorry. So the vertex for Jerry is at 8, 16. His y-intercept, if you sub in 0 for x, you end up getting 12 as well, which makes sense because your y-intercept is 0, 12 on both. Well, if you think about the problem, it says you're jumping off a 12-foot diving board and x is a distance in feet from the diving board. Well, if you're at a distance of 0 feet from the diving board, that means you're on the diving board, so you should be 12 feet in the air. So it makes sense. All right, so let's go to our graph. Now let's think about this. This is our distance in feet. Okay, this is my height. Sorry, I got a little close to the graph there. In feet. Okay. All right, so if you notice, our axes are removed here because think about what you're looking at. You're looking at distance and you're looking at height. The only logical way to describe distance and height are in positive values. You're not going to say, I threw a -15 yards. I drove a -10 miles. I am -2 feet tall. It just doesn't make sense, okay? So you really want to make sense. A lot of these problems are going to end up in the first quadrant because in context we deal with positive numbers, but then again, you never know. Sometimes you might be dealing with something like going underwater. This problem is talking about a diving board, but it's not underwater. But if you're talking about underwater, you could have a negative height. That just means you're underwater. So you're really going to have to click that logic part of your brain on here and think through these problems, okay? So let's graph what we know. We know that Tom has a vertex of 3, 5, so 3, 15. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 15. So he's here. And his y-intercept is at 0, 12, so here. Okay. Now I can do a symmetric point. For this, we went left 3, down 3. So I can go right 3, down 3, and at least get another point without having to do much work. Now, your a value there is -1/3, which means you would go over 1, down 1/3, over 2, down 4/3, over 3, down 3. Okay, so some of them are going to be pretty, but that gets really, really messy, okay? And I know that this x-intercept is messy, so this is what we're going to talk about with the calculator, okay? So grab your calculator. This is the only thing we're going to use calculators for, is to calculate x-intercepts that aren't pretty. So obviously if we're not allowing you to use a calculator, that means you should have nice x-intercepts, okay? So what you're going to do is you're going to take your calculator, clear out whatever. I always clear out my home screen, clear out anything. Go to your y equals. So you guys know how to graph y equals from last year, okay? Make sure all of your plots are off. So you guys, if you have anything like this on, your screen looks like this, arrow up, turn it off, okay? Then you have y1. If your screen looks anything not like this, and you're not sure why, you guys, you need to come talk to us right away, okay? So I'm going to put in my first function, which is -1/3 x squared, okay? Remember, your fractions always need to be in parentheses. Your squared key is over here. The x key is up here. All things you should know, okay? This is plus 2x, I believe. Let me double check here. Yeah. Okay, plus 12. Okay, now let's think about the window. If you hit zoom and 6, which is zoom standard. Okay, you guys, if you're doing this with me and which you should be, and this is too fast, obviously pause the video, make sure you do the steps I say. So I just hit zoom standard. Well, this isn't really giving me a good representation of the graph. Okay, so go to your window. Remember in Math 1 you messed around a lot with windows and things. So this is coming back to what we said about what makes sense. My x is representing distance. I'm going to start my x at 0. So that x min is where I want my x's to start. So let's think about x max. The problem said that they want to at least jump 20 feet. Okay, so I never just go to the 20. I'm going to go to 25. I always go a little bit past it. I want to get a good idea of what the graph looks like. The scaling means obviously scaling your graph. How often do you want a point plotted? And we'll just leave it at 1. 0 to 25 isn't bad. Now with your y's, we're starting at 0. And then let's think about height. Well, we found two vertices, excuse me, a vertex for each. Well, that we know is the highest point on the graph. Both of these graphs are opening down because they have a negative a value, and that's going to be your extremum. That's your highest point. That's what that vertex is. That's why it's important. Well, we have one vertex that goes as high as 15, one vertex that goes as high as 16. So I'm going to go up to 20 because I know I'll get the whole graph in there. Now when you hit graph, you should see a nice picture. Okay. So this is what is new for you. Okay. So far nothing's new. You guys all know how to graph and y equals. You all know how to mess with your window, but it's really making sense of what's going on here. You're going to hit second and you're going to hit trace. So it's this button right here between zoom and graph. Option number 2 says 0. Your calculator calls x-intercepts zeros. So we're going to go down, hit enter. Now, if you notice, your graph is asking for a left bound and a right bound. Anytime you do these types of things on the graph, right now we're just doing x-intercepts, but we'll build on it. You have to give your graph a window, or your calculator a window to find what you're looking for. So you can't just say find the x-intercept anywhere on this graph because we have multiple x-intercepts. So we're going to tell it, okay, where should it be? Now, left bound. If you arrow your cursor to the left, you can never hit up or down here, you guys. If you use these up or down keys, it goes off the graph, so don't do that. So do you see how my cursor is blinking here? Well, I know that my 0 is somewhere down here, kind of behind that 8 and 0, right? So if you see where my arrow is right here, technically my cursor, just think left or right, is to the left of the 0. Notice I have a positive y value. Okay, I'm going to hit enter. Two things happen. It switches to right bound and it gives you an arrow. Okay, if you have a nice new calculator, it's going to give you a line, which is even better. Okay, so now right bound. That means I need to get my blinking cursor to the right of the 0. Well, if you notice, it disappears, right? Well, think about it. An x-intercept has a y value of 0. If you were to the left of it, we were above it, so we were in a positive y value. If you are to the right of it, that means you've gone down past it. So see how my y values change to negatives on my calculator here? As long as you have a negative y value, you're good. It does not matter which y value it is, okay? When you hit enter, two things happen. You get another arrow or another line. So this is the interval that your calculator is going to find an x-intercept in. Okay, it also says guess. You guys, you do not need to try and make a guess. All you need to do is check, make sure that you have the correct interval and hit enter. Until your screen says 0, it's not an accurate answer. Some people get to guess and write that down. Be really careful that you're paying attention. Now, if you at this point get an error that says no sign change, that means you either tried to pick two positive y values or two negative y values. You are always going to need a positive and a negative here, so you're on either side of 0. Okay, so this tells me that my 0 here is 9.71 when we round it and round it correctly. So I'm going to come here and say, okay, well 9.71, this is 789, so 9.71 is about here. Okay, and I'm just going to make that note. Okay, so this is Tom's path. Now, before we go and answer the question, let's finish Jerry's graph. Jerry's also at 0, 12, but his vertex is at 8, 16, so he's over here. Okay, now we went over 8, down 4, so I can go over another 8 and down another 4 to find a symmetric point. Okay. Now for my y or my x-intercept, I'm going to do the same thing. I'm going to go back to my y equals. I'm going to clear out that y equals, and I'm going to put in my new function. So negative 1 divided by 16 here, x squared, plus x plus 12. Now, I'm not going to change my window. I'm not going to touch anything. I'm not going to hit zoom standard or anything like that. I don't need to change my window because I set up the dimensions for this entire problem. I paid attention to everything I needed. So I'm just going to go ahead and hit graph. If you hit zoom standard again, you're going to have to redo everything. So we have a nice graph here. We already know what these points are up here. We need to find this x-intercept. So again, you hit second, trace. Your calculator calls an x-intercept as 0, and in a few months, not months, weeks, you'll know why. Okay, now we need a left bound. So to be to the left of my 0, which is right about here, I need to be above it. It doesn't, I could click enter right now. It doesn't matter. Okay, so I'm here. Now to be to the right bound, I need a negative y value. Remember, if you're dealing with a 0, you need a negative and a positive. So I went pretty far, so you can kind of see that my interval is almost off the graph, but it's going to find something between here. Hit enter. You should get 24, 0. Now, this for us goes off the graph. This is 20, so I'm just going to eyeball it out here as 24. And this was Jerry's chum. Okay. Now, we said, the question was, sorry, do either Tom or Jerry make the distance? If so, by how much? A couple things you guys pay attention to, not only the first question, but the last question. You remember we want these answered in complete sentences. So here you can clear, remember we wanted to go 20 feet, which is right here. Okay, so Jerry very clearly made the distance, whereas Tom did not. So we're going to say Jerry made the distance by 4 feet, because it says if so, by how much. And then just be thorough. I'm going to keep going and say, and Tom missed the distance by about, well, we wanted to go 20. He made it about 9.71, so by about 10 point, I think that's 29 feet. Okay, that's how much he was short. That is a very thorough, perfect answer to the question. Okay, so quick recap. I didn't do anything new in the blue or the orange. Yeah, we had fractions, that kind of makes it hard, but not that hard. Okay, the new thing was finding these x-intercepts on the calculator. Cool, that's the only thing you should pick up your calculator for. The absolute only thing. Okay, all right. Now, that took me quite a while. Obviously, I was explaining it to you in detail. These problems are going to take you longer. They're not going to take you 18 minutes like it just took me, but it is going to take you probably like 4 minutes per problem to really make sense of it. And the more you do, the better you get. You guys, I cannot stress enough that practice here is so crucial. It always is, but even here, the more you see, the more you know. All right, so I'm going to go through this one a little bit quicker. Okay, it says Coach Quatman was having a contest with his quarterback on the football team as to who could throw the ball farther. There are 2 receivers waiting downfield to catch the balls, both standing 32 feet from Quatman and his quarterback. So that's something that we want to pay attention to. Quatman's throw can be modeled by the quadratic equation of that. Okay, and you should pick up on the fact that, oh, hey, now we're dealing with vertex form instead of standard form. And the quarterback's throw can be modeled by this. Okay. In both cases, x represents the distance in feet since the ball was thrown, and y represents the height in feet. So if you notice, this is already given to you as the first quadrant because you have a distance in feet and we have a height in feet. So again, you guys, just like the last problem, it wouldn't make sense to have a negative y value. If I'm dealing with height, that means this is the ground. Okay, if I'm negative, I can throw that ball underground. Distance. If I'm negative, that means I threw the ball behind me. Okay, and then something went disastrously wrong in this problem. Okay, so really use that common sense here. Turn that logic on. The first question said, who threw the ball higher? Okay, well, part of this, you guys, is figuring out what part of the graph you need and when. If I'm asking for who threw the ball higher, you should be thinking, higher, maximum. Maximum's my extremum. My extremum comes from my vertex, okay? That's how you should be thinking. So I'm going to say, okay, well, Quatman's vertex is 1620. It's in vertex form. I can just pull it right out. Remember, if you're coming out of the parentheses, you take the opposite. The quarterback's vertex is at 1326. Okay. Now, this question is asking who threw the ball higher. Well, if I'm dealing higher, height is my feet in, or the height in feet is my y, so I'm focusing on this. So I would say the quarterback threw the ball higher by 6 feet. You can never go wrong with more detail. Okay. So the explain part is kind of saying, if you say the quarterback threw the ball higher, that's great. You're answering the who threw the ball higher. But if you explain simply by saying 3 extra words, by 6 feet, you're saying to me, hey, I understand that it's my y value. I know what I'm comparing, yada, yada, yada. Okay? Give detail. This is something you should really, really, really practice. Check your answers. If they're slightly different than the answer key, come ask, okay, you guys, because sometimes you're right, sometimes you're not right. So there's no harm in asking, okay? Now, part B said, did they both make it to their receivers? Explain. Well, their receivers are standing 32 feet away, okay? So if you think about it, where are they standing? Well, they're standing right here, okay, because it says X represents the distance since the ball was thrown. Well, they're throwing it from here. So we're going to see some sort of trajectory, and we want to see if they make it 32 feet. Okay, so I'm trying to find, sorry if that was choppy. I had to pause the video for a second and kind of lost my train of thought. I have to find my x-intercept. Okay, think about this. I'm trying to figure out if they make it to the receiver. So if my receiver standing here, that's an x-intercept. So I'm going to go ahead and pick up my calculator. Okay. And we can do Quatman first. We have negative 1 over 18 x squared. Nope, totally kidding. Sorry. X minus 16. Forgot we were in standard or vertex form. X minus 16 squared. There we go. Notice I used 2 sets of parentheses there. Plus 20. Okay. Now, if you think about our window, we want to clear out our window from the last one. I'm not even in graphics, so no, it's not going to work. But again, distance in feet for my x, so I'm going to start at 0. Now, my receivers are 32 feet away, so I'm going to go a little bit more. I'm going to go to 40. You want to get a good, accurate picture. You don't want to hit 32. You want to give yourself some breathing room. Okay, that's kind of how I think about it. So we're going to go from 0 to 40. Now, if you think height, again, we're starting at 0. That's the ground in this case. Now, how high do we want to go? Well, in part A, we just figured out how high they went. Quatman threw it 20 feet in the air. The quarterback threw it 26 feet in the air. So the highest it's going to go is 26 feet. So I'm going to go up to about 30. Give myself some room, but then I can see a nice big picture. So now when you hit graph, you should see this. Okay. And now, again, I'm going to find my x-intercept. So second, trace. This is the exact same process every single time. You need to know how to do it. We will not tell you how, but you do it by practice. Option number 2 is 0. Okay, you guys, I can't stress enough. Your left bound and your right bound, you need a positive and a negative y value because you're trying to get on either side of 0. Well, either side of 0, one side's positive, one side's negative. So I'm going to choose above. I'm going to wait for my y values to drop negative. And so we're at 34.97 feet. So Quatman has a x-intercept of 34.97. Okay, obviously these are approximate. We're not going to put approximate symbols in a point. Okay, so we know Quatman makes it because he's 32. The receiver's 32 feet away. Quatman throws it 34 feet. Now the quarterback, we're going to do the same thing. I'm going to go back to my calculator, go to my y equals. I'm going to put in my other function. I'm not going to change my window because I set my window for the entire problem, not for one graph. Don't set it for one graph, that won't help you. Okay, Oh, but you might want to put it in right because that's totally wrong. What did I forget? Oh, this does not need to be squared. Okay, you guys, actually, I'm glad that happened. Whenever something happens and you go to your graph, and like this very clearly doesn't make sense, the very first thing you should do is to go to your y equals, and you should double, triple check that you put it in correctly. I can very clearly see that this squared shouldn't be there. So you just hit delete, it goes away. So you have negative 1 over 7 times x minus 13 squared plus 26. It looks good now. There we go. That makes way more sense. Okay. So you're going to hit second, trace, 0. Notice I'm doing the exact same thing every single time. Okay. We need a positive. Make sure your y values drop negative. And the other quarterback is 26.49. So we have 26.49. That's obviously an approximate. Okay, sorry, that looks more like a comma. All right, so if you look, did they both make it to the receivers? Well, Quatman obviously did. The quarterback didn't. So again, you guys, the more detail, the better in these answers. So I would say Quatman did make it to his receiver. And he has about 2.97 extra feet. And the quarterback didn't, he was short by about 5.51, so 5.5 feet. Okay, so that's a very thorough answer, and you can be sure that you would answer the explain part of it. Okay, notice I didn't graph this at all. I wasn't asked to. I don't need to. It's just there if you need it. Okay.